Hello Year 11 and welcome to our fourth video here on indices and logs. In our last exercise we were introduced to logarithms and we learnt what that notation represents. Today we're going to interpret some of the laws that relate to logarithms, right, to our log laws. They're very much like our index laws. Okay, they'll allow us to simplify the manipulation of logarithmic expressions. The first of these laws is that the log of AB is equal to the log of A plus the log of B. Okay, so for example, if I knew that the log base 3 of 4 was equal to this, the log base 3 of 5 was equal to that, then and if I were asked to evaluate the log base 3 of 20, well, I might be able to reason that 20 is equal to 4 times 5, right? So the log of 20 is the log of 4 plus the log of 5, assuming we keep the same base throughout. I've got the log of 4 and I've got the log of 5, so I can merely add those together and I get 2.727. Yeah. Our second law. So if the log of A times B is equal to the log of A plus the log of B, the log of A over B, or A divided by B, perhaps we might reason is the log of A minus the log of B. Okay. And so an example, again, using these values that we had, evaluate the log base 3 of 0.2. Well, that's a bit of an issue, isn't it? 0.2. How can I represent that in terms of perhaps 4s and 5s? Well, maybe I might think of it as the log of 1/5. 0.2 is 1/5. 1 is still a little bit of a problem. Okay, but coming back to our understanding of logarithms, 3 to the power of what equals 1, right? If I'm after, right, the log of 1 minus the log of 5, because it's 1 divided by 5. 3 to the power of what equals 1? 3 to the power of 0 equals 1. So this becomes another law that we'll learn soon, that the log of 1 is equal to 0. So it's 0 minus the log of 5, right, which equals negative 1.465. Yeah. So that was a bit tricky there with our second log law. So two so far. The log of AB is the log of A plus the log of B. The log of A over B is the log of A minus the log of B. Now, the log of A to the power of B, right? We might think, if that, for example, were a 2A squared, that would be, right, the log of A times A, which we know is the log of A plus the log of A, which would be 2 times the log of A. More generally, here the log of A to the power of B is B times the log of A. Again, pretty handy. So, using those values above, we're asked to calculate the value of the log of 2. Well, again, I've got a 4 and a 5. How does that relate to this? Perhaps we could think of 2 as 4 to the power of 1/2. Right? 2 is the square root of 4. Right? Another way of saying square root is to the power of 1/2. So that's 4 to the power of half, which is 1/2 of the log of 4, which is half of that value we were given, which is about 0.631. Right. Moving along now, we discussed this earlier in the solution to our second example there, that the log to any base of 1 is equal to 0, right? Because anything to the power of 0 equals 1. The log of any number to the same base equals 1, right? A to the power of what equals A? A to the power of 1 equals A. So the log of itself equals 1. Now, suppose we can rearrange that and combine some other laws and say that the log of 1 over A is negative 1. Okay, we could say that's A to the negative 1, if you like, we're using a negative index, and then the negative come out the front would be the negative of 1. The log of the square root of A, right, that's a to the 1/2, the half goes out the front, equals 1/2. Now, these last two here will become more important with our next exercise. But a to the log base a of x equals x, and the log base a of a to the x equals x. Now, for this second example here, well, we can use the third law there, put the x out the front. I get x log a base a. So that's fine. That's x times 1 equals x. Here, it's a little more complicated, I suppose, but it's important that we remember those two relationships, or those two log laws as well. So quite a lot to take in there. Some of them easier to remember than others, perhaps. Some of them not so critical. I find things like 6 and 7 here, that I can interpret those fairly well, mostly using the third law. 4 and 5 are important enough in their own right, but they sort of make a bit of sense. It is important you remember them. They will help simplify expressions. 1, 2, and 3, as well as these here for 8, I think are particularly important to commit to memory. And practicing these exercises that follow will be important with that. So make sure you do that and spend some good time doing it. Here's a recap of those 8 laws that we learned about today. Okay. Those 8 laws, particularly important that through practice and repetition, the first 3 and the last one, I think, that you become very familiar with those. So that's it for this exercise. If you've got any questions, you know what to do. Jot them down, ask me during our meeting. Other than that, our next video, just for a bit of a teaser here, a bit of a preview, is going to be solving log equations. Okay, solving equations with logs. That'll be fun. Okay, well, I'll see you in the meeting. Enjoy.